Alrighty, folks, this is going to be the third and last video for Note 69. This is going to be on domain, range, and zeros. So in this first part here, we've got a problem that I'm asking you to find the domain. So let's go ahead and mark domain. I also want to know the range and, of course, the zeros. So domain, remember, are your possible x values. So when we look at these ordered pairs, actually, I'll go ahead and highlight it. Nope, highlighter, there's the blue. Okay, we've got 9, -2, 6, and 4. So those x values become the domain. All right, so I'm going to put it in numeric order. You don't really have to. It's kind of nice to do it just to make sure you get all your points in the right order. So let's see, -2, 4, 6, and then 9. And then separately, go ahead and grab pink there. I'm going to grab the y values for the range. Okay, again, I'm going to put them in numeric order. So let's see, 0, then 3, 4, and 12. And I'm going to delete all that stuff. And the last part here is the zeros. What makes the function equal to 0? So when I look for that, I'm looking for y to equal 0. And then what's the x value? And the only x value we have here that makes our function equal to 0 is 6. All right, so that is the answer for number 6. We found the domain, we found the range, we found, in this case, the zero singular. All right, so then if I slide on down, I think that was it for that part. Yep. Number 7 is A, B, and C, and I'm asking you to find the domain and the zeros. So let's start with part A, domain. So domain for part A, we're going to be looking for two things. I want any kind of square root to be not negative. I don't have a square root in this problem. And then I want any kind of fraction. I don't want the denominator to equal 0. And that doesn't have a square root or a fraction. So your domain is, there's no restrictions. So -infinity to infinity. All right, everything is fine there. To find the zeros, we're going to take the function and simply set it equal to 0. Okay, whoop, that's not 18. There we go, 15. And then we're going to solve this. I'm going to attempt to factor it. I believe it does factor, so let's see what I get here. If I do 5 and 3, make the 5 positive, 3 negative. Okay, quick check. 5 times -3 is -15. And then 5 minus 3 is positive 2. Yep, we are all good on our factors. So to find the actual zeros, we're going to set each factor equal to 0. So x equals -5, and then x equals 3. So my zeros, and you can write this a couple different ways. You can put x equals -5, and then I'm going to do a little comma for 3. That's fine. You could simply say -5 and 3, right? You got a couple options there. All right, so that is the answers to part A. Now we're going to start it again for part B. Okay, so when I'm looking for domain, I'll put this off to the side here, domain. Domain, I'm going to be looking to see what makes any kind of square root. I need to be not negative. I don't have any square roots here. But I do have a fraction. And when we're dealing with fractions, you cannot let the denominator equal to 0. So this is going to sound a little bit weird, but I'm going to purposely set the denominator equal to 0 to figure out what my issue, right, my issue number is. So if I subtract 8, right, I'm going to get x equals -8. And if I put -8 into my function, I create this whole, some number divided by 0 that's undefined. So for the domain, I am going to allow my x to be anything it wants to be except -8. So I'm going to go -infinity, -8, and then -8 to infinity. So we're going to go from infinity to infinity, but we are excluding one specific value, which is -8 in this case. So that's my domain. Now for the zeros, all right, because we've also got to find zeros here, or zeros plural, if we have multiple. Okay, that means I'm going to take my function, set it equal to 0. So x minus 2 over x plus 8. So that means I'm going to multiply by x plus 8 on both the left and right side. On the left side, x plus 8 times 0, well, that's still 0. Kind of nice to work with zeros that way. And on the right side, x plus 8 in the denominator will take out the multiplier of x plus 8. So I'm left with x minus 2. I'm going to add 2 to both sides, and I get x equals 2 as the single 0. So my 0 in this case is, well, x equals 2. All right, and that value of 2 is absolutely valid as part of my domain, so no issues there. So answers, kind of zip it in there. Domain is going to be from negative infinity to negative 8, then negative 8 to infinity. And then my 0 is x equals 2. That is the value that will make my function equal to 0. All right, we're going to do it one more time for part C here. In this case, we do have a square root. So when we talk about domain, what I have to do is make sure that this expression underneath the square root cannot be negative. So the way I deal with that is I am going to take the expression, so 3x minus 5, and I am going to purposely set it greater than or equal to 0. So the greater than 0 part is what makes it positive. That's good. Positive numbers are okay. The equal to 0, yeah, it's okay to take the square root of 0. That's fine for this particular problem. So solving this, we've got 3x. I'm going to add 5 to both sides. So divide by then 3. So x is greater than or equal to 5/3. Visually, okay, if you don't need this, you don't have to do this, but if it helps, it helps. Visually, I'm looking for then values that are greater than 5/3. And at 5/3 itself, the equal to part means I'm going to use that bracket there. So my domain here is going to start from 5/3 and go to positive infinity. But then I want to find my 0, right? What makes this function equal to 0? So let's see. 0 is equal to the square root of 3x minus 5, right? Make the function equal to 0. To get rid of a square root, we're going to go ahead and square both sides. So 0 squared is still 0. Okay. On the right side, then, the square root and the square cancel each other out. They are inverse operations for a reason. I'm writing a little bit larger than expected. Shocking, I know. So add 5 to both sides. So 5 is equal to 3x divided by 3 on both sides. And I am getting a 0 of x is equal to 5/3. All right, so that is the final answer for part C there. We found the domain, 5/3 to infinity, and then at 5/3 itself, that is when your function is equal to 0. All right, so there's all the work that we've just done. There it goes for domain, range, and zeros. If you have any questions or concerns, please let me know, but that's going to wrap it up for Note 69, and I'll see you in the next one.